At some point in mathematics you'll come across simultaneous equations and will need to know how to solve them. The equations, so a statement that the values of two mathematical expressions are equal, and for the simultaneous part, occurring, operating or done at the same time. So you must be able to substitute numbers, solve simple equations and manipulate algebra. So this video is looking at what's called the elimination method. There are other methods to master, substitution and by using graphs. I'm going to jump straight in and look at a worded example because this just gives a better idea as to why we use simultaneous equations and how useful they can be, especially with saving time. So in this particular case, Emma sells 300 tickets for a concert. Some tickets are sold to adults for £5 each, and some tickets are sold to children for £4 each. If she collects in £1,444 in ticket sales, how many tickets have been sold to adults and how many tickets sold to children? Now, if you think about this problem, if she were to work this out without using the method of simultaneous equations, she would have to go through perhaps all the receipts to find out exactly how many adults and exactly how many children's tickets are sold, and that might take quite a while to do. But as you'll see now, using a particular method, this could be done much quicker, and that's the whole point of knowing how to do the simultaneous equations. You've got something extra in your toolbox that allows you to work something out much quicker. So what we're going to do is we're going to look at what's going to represent the number of adult tickets and what's going to represent the number of child tickets. So let's just go back to the information that we've got here. If we just highlight the important information, so here we have 300 tickets that are sold, and we have a mixture of adult tickets, which are £5, and children tickets, which are £4. In total, 1,444 are sold. £1,444 worth are sold. So in terms of the numbers of adult tickets, the number of child tickets, and when we're adding together the number of adult tickets and the number of child tickets, that will come to 300. Let's just check that. 300 tickets were sold, adult tickets and children tickets. So here we have the first of our simultaneous equations. The number of adult tickets plus the number of child tickets will equal 300. Looking back at the other information that we have that for each adult ticket costs £5, each child ticket costs £4. So we can say that for each adult ticket, which costs £5, and then we have the child ticket, which each costs £4, and the total for all of that was £1,444. Okay, so we've got the number of adult tickets at £5, so we can multiply those. certain number multiplied by the £5 plus the certain number of child tickets multiplied by the £4 will equal the £1,444. Now, at the moment, I've just been using these images to represent that. With algebra, as you know, we use the letters to help represent. So we can replace these images here with these letters. So we have that x plus y equals 300, and then we have that the £5 multiplied by the x plus the £4 multiplied by the y equals the £1,444. So here we've formed two simultaneous equations. Whatever we're going to find out for x will work for both of these. Okay, so here's our information again, and what we're going to do is, as we would with the elimination method, we're just going to label these. So this is the first and this is the second, just so that we can reference them a lot more easily. Now, I'm going to do this the long way first of all. Just looking at these here, if we were to say, right, we've got 5 x's, we've got 4 y's, and we've got 1,444, let's see what we can take away here. So we've got 5 x's, take away an x, 4x, 4 y's, take away a y, 3 y's, 1,444, take away 300, 1,144. Now, what we want to get down to is we want to eliminate one of these letters. And if we keep on taking off one of these, eventually we will eliminate one of the letters. So let's just have a look. 4x, take away x, 3x, 3y, take away y, 2y, 1,144, take away 300, 844. And we can do this again. And I'm sure by now some people have spotted that there's a much quicker way than doing this. But that's what we'll look at on the right hand side in just a moment. 544. And again, you can see what's going to happen next. So as you can see at this last step here, we're going to end up with an x, 2x, take away 1x is x, y, take away y is 0, we don't need to write that, 544, take away 300, 244. So we have that x equals 244. Well, as x is 244, so if this is 244, then y must be the difference between 300 and 244. So y must be 56. And you can check that by substituting x is 244 into this one, and y equals 56 into this one. And when you've substituted those in and worked it all out, it will come to the 1,444. And you can do that if you don't believe me. Now, as I said before, this is the long way of doing this, but this is the elimination method. Now, going back to why these were labelled as 1 and 2, well, in case you haven't figured it out yet, what you can do is, once they're labelled 1 and 2, what we've basically done is we've had equation 2, 2, 3, 4 lots of equation 1. So we've got equation 2, take away 4 lots of equation 1. So that means we would have 5x plus 4y equals 1444, and we're going to be taking away 4 lots of equation 1, so that is 4 lots of x, 4 lots of y, and 4 lots of 300. Okay, so we're going to subtract these two. 5x, take away 4x, left with x. 4y, take away 4y, nothing. 1444, take away 1200, 244. So it's exactly the same as what we've done there, apart from we've used the information that we're aware of just to make it quicker. So that's labelling up the two equations and deciding which one to eliminate in terms of the unknowns, so the x and the y, different letters depending on how it's set up. Going to look at two further examples. Looked at one which started from a worded question, just to show you how useful it can be in solving something that could take a lot of time if it wasn't for using the method of solving simultaneous equations. Now, just looking at some simultaneous equations, just to fine-tune the method behind it. So, looking at this first one, because we're looking at the elimination method, we want to know which of the letters we can eliminate. Now, we can see here that the number of u's are the same in both of these, so it makes sense to eliminate the u's in our first step. As before, it's best practice just to label them up, and what we're going to do is we're going to have this equation, equation 1, and we're going to take away equation 2, and we'll just reference that here, 1, take away the 2. So that means that we're going to have 3t, take away t, 5u, take away 5u, 0, and 30, take away 20, 10. So we've got 2 lots of t is 10, so 1t must be 5. Now that we've got what one of the letters has the value of, we need to find out what u has the value of. And we can just substitute that into one of the equations. It would make sense to substitute it into this one, as there's a bit less work for us to do. So we have 5 plus 5 lots of u equals 20. So it's just substituted in that t is 5 into this here. So as you have knowledge of solving equations, 5u is going to equal 15. We've subtracted 5 from each side. So we've got 5 lots of u is 15. 1u will equal 3. So we now have that t is 5 and u is 3. And you can double check that by using the other equation there. So we have 3 lots of 5, 15, plus 5 lots of 3, also 15, equals 30. So you know by checking that those are correct. It's always good to check after you've solved. For the next one, we can see here that the number of p's are different, 5 of them, 1 of them, and the n's here. Now we've got a coefficient here where it is -4 and a coefficient where it is +4, but we can still eliminate, but this time rather than subtracting we can add these together. So equation 1 add equation 2, and when we add them together, so we have 6p, the -4n plus 4n, well that will take us to 0. and so therefore we've eliminated the n's. 46 plus 14, 60. So I have 6 lots of p is 60, so 1p will equal 10. Just as before, we can substitute it in. So we have 10 plus 4n is 14. Okay, so just taken from equation 2 there. So solving this simple equation, 4n will therefore equal 4, so subtracting 10 from both sides. And if 4 lots of n is 4, one of those n's will equal 1. And again, we just need to make sure we can check that to make sure that is correct. So if we use the other one just to check, we've got 5 lots of p, so 5 lots of 10, that's 50. Take away 4 lots of n, so we're taking away 4 lots of 1, which is 4, so we've got 50. Take away 4 is 46. So those are both correct because we've just checked them and it works. Always a good idea to check them. Here are some questions for you to try out. The best thing to do is to write them down, solve them using the methods that you've just been shown, using the elimination method. E and F are a little bit trickier, so just see if you can work those out yourself to start with. If you need to rewind the video at any point just to remind yourself what to do, then that's what you can do, but at this point it's best if you just pause it, answer the questions, and then unpause it to just double check your answers or see what the methods are in order to solve. Okay, so you've just spent some time having a go at solving these. So let's just go through them then. So as usual, we will be labelling these. And in this case, it would be much better for us to have equation 2 take away equation 1. Now, if you did equation 1 take away equation 2, that's not a problem. You just probably ended up with working with some negatives instead. Okay, so equation 2 take away equation 1, so that's 5x. Take away 2x is 3x. 3y take away 3y is 0. 23 take away 11 is 12. So we've got 3x is equal to 12. So that means that we have x is 4. When we substitute that in, 5 lots of 4 is 20, plus 3y equals 23. So we can see now that 3y must equal 3, and therefore y equals 1. Let's just double check that. So we've got 2 lots of 4 is 8, plus 3 lots of 1 is 3, 8 plus 3 is 11, so we know that those two are correct. For question B, so we've got equation 1, equation 2. Here we can see that we've got the same number of y's here, so we can just have equation 1 take away equation 2. As with A, you could have equation 2 take away equation 1. If you did that, you get some negatives. Doesn't really matter. Might make it a little bit more difficult. Just depends on which you prefer working with. So in this one, equation 1 take away equation 2. 5x take away 4x is x. Y take away y is 0. 12 take away 10 is 2. There's nothing more to do. We can see now that x is equal to 2. Let's substitute that in. 4 lots of 2 is 8. Plus y equals 10, and we can see here that, well, y is going to be 2. 8 plus 2 is 10, y must equal 2. We'll double check that in the other one. 5 lots of 2 is 10, plus 2 is 12. So again, we know that those are correct. On to part C. as usual, labelling them. This time we have a plus y and a subtract y. So we're going to have equation 1 plus equation 2, because when we're adding these together, we'll eliminate the y's. So we have 9x, 5x plus 4x is 9x. We have a y plus a negative y will equal 0. And then we've got 17 plus 10 is 27. So we've got 9 lots of x is 27. So 1x will equal 3. So if x equals 3, 4 lots of 3 is 12. Take away y equals 10. We can see that we'd have to take away 2. So y is 2. Let's just double check. 5 lots of 3 is 15, plus 2 is 17, so x is 3, y is 2, they're both correct. Part D, again labelling them 1 and 2. Here we've got plus 3y, subtract 3y, so that means that we're going to be adding the two equations together just like we did for part C. 4x plus 5x is 9x. They're going to eliminate 0. 22 plus 14, 36. That means that x is going to equal 4. 4 9s are 36. Using the fact that x is 4, substitute in 5 lots of 4 is 20. Take away 3 lots of y to equal 14. So we can see now that 20 take away 3 lots of y is 14. We're going to take away 6 to get 14. So therefore 3y will equal 6. So y will equal 2. Let's just check that. 4 lots of 4 is 16, plus 3 lots of 2 is 6. 16 plus 6 is 22. Therefore we know that those are correct. Going across to part E now, this is where it gets a little bit more complicated. So we've got equation 1, equation 2, and this time what I'm going to do is I'm going to have 2 lots of equation 1 and then take away equation 2. So 2 lots of equation 1, so that's 4x. Take away what we have for equation 2, 3x. 4x, take away 3x is x. 2 lots of y, take away 2y is 0. So that's how we've been able to eliminate the y's. And then we've got 2 lots of the 9, 18, take away the 14 is 4. So we've got x is 4. Okay, if you weren't too sure about that, you might want to just rewind a little bit and just listen to that again. So now we've got x equals 4. 3 lots of 4 is 12. So we've got 12 plus 2y is 14. So we can see that 2y is equal to 2. So y must equal 1. Let's just check that in the top here. So we've got 2 lots of 4 is 8, plus 1 is 9. So yes, those are correct. And for the very last one, labelling them again, we could decide to have equation 1 take away 5 lots of equation 2, because then we'd have 5x. 5x take away 5x, it would eliminate the x's. Or we could have equation 1 take away 3 lots of equation 2, because then we would have 3y take away 3y and eliminate the y's. and that's what it's going to do. It's going to have equation 1 take away 3 lots of equation 2. So that's going to be 5x take away 3 lots of this, so 3x. 5x take 3x is 2x. 3y take away 3 lots of this, so that's 3y, take away 3y is 0. And then 16 take away 3 lots of 4, so that's 16 take away 12 is 4. So I've got 2 lots of x is 4, so 1x is 2. So I'm going to use that, substitute in. I've got 2 plus y is equal to 4, so y must equal 2. Let's just check that then. When x is 2, 5 lots of x is 10, y is 2, 3 lots of 2 is 6, 10 plus 6 is 16. So again, we know that those are correct. Please let me know how you got on in the comments. If you have any questions, ask away. If you have any suggestions, please leave constructive suggestions as well.